Hey guys, today our topic is section 4.4, the distance formula. I've got the distance formula written up here, but we're going to do one example here by plotting 3 points. Point A, negative 2, 2, point B, 5, negative 1, and point C, negative 2, negative 1, to show how what we've learned the last 2 days, the Pythagorean theorem, is very much related to and where the distance formula is derived from. So if you guys want to pause the video for a moment so that you can write down this example and get those points plotted, go ahead and do so now. All right, now that you have that written down, we can take a look at this first example here with point A, point B, and point C. The question asks to find the distance from A to B, this distance in blue right here. We can show this by doing the Pythagorean theorem. Notice if we count the straight vertical distance from point A to point C, we can see that that's going to be 1, 2, 3 units. So I'm just going to put a 3 right next to side AC. We can also count the distance from C to B, that straight horizontal distance. If we count that distance from C to B, it's 1, 2, 3, 4, 5, 6, 7 units. So I'm going to write a 7 next to that segment from C to B. Notice you can probably come up with the idea that at angle C, what type of angle does it appear we have? It looks like it's a right angle, and if that's what you thought, you're correct. There you go. And so you can see we now can use what we learned the last couple days to calculate the distance from A to B. A to B would be the hypotenuse in a Pythagorean theorem problem. So with this drawing, we can use the Pythagorean theorem, c squared equals a squared plus b squared, to calculate the distance from A to B. That would be c squared equals 3 squared plus 7 squared. If I continue, I get c squared equals 9 plus 49. C squared equals 58. Hopefully remember our last step with Pythagorean theorem because it's the same step on the distance formula today. Take the square root of 58. I realized I didn't have my calculator out, so I need to grab that quick. And that would be 7.6. So our distance from A to B is 7.6 units. Now a quicker way to do that without having to plot this graph, we can very quickly use the distance formula. So I'm going to use, use this exact same example to find the distance from A to B. So for this example over here, rather than graphing, I'm just going to use this coordinate and put that into this formula. If you want to take a moment and pause the video so that you can write this formula into your notes, go ahead and do so now. Okay, to find the distance from A to B, we're going to use the coordinate negative 2, positive 2, and point B was 5, negative 1. Make sure you follow along because I am going to erase this example after we complete it. This should look familiar to you. When we did the midpoint formula, we labeled this point x1, y1, this point x2, y2. Now we can place these numbers into the corresponding spots of this formula, and it's just a bit of calculator work. We can put negative 2 and 5 into an x1 and x2. We can put 2 and negative 1 into y1 and y2. I'm going to go ahead and do that now. As we start to make these calculations, you're going to see some of the same numbers from here come up on this distance formula problem. So we've got d equals the square root of negative 2 minus 5 squared plus 2 minus negative 1 squared. All of that is under the square root. So as I calculate here, I've got the square root of negative 2 minus 5. That would be negative 7 squared. 2 minus a negative 1. That would be 3 squared. Notice you're starting to see some of the same numbers come up from here, and they're over here in the distance formula as well. That shows you that this distance formula is just another version of Pythagorean's theorem on a coordinate plane. To finish this problem, we'll say that d equals the square root of 49 plus 9. D equals the square root of 58, which is about 7.6 if we round to 1 decimal place. Let's do one more example together, and then you can try some examples on your own. Again, you can pause the video for a moment if you need to fill in any spots that you didn't have written down here. Okay. For the last example, let's pick 2 new coordinates. Again, we'll use the distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. The 2 coordinates we'll use this time are 0, 4 and 5, 2. Again, we'll substitute these into the formula. We can label this x1, y1, x2, y2. Once you do that, it's a matter of putting these in the right spot. Put the x's together, 0 minus 5. Put the y's together, 4 minus 2. Let's go ahead and set that up together here. So distance equals the square root of 0 minus 5 squared plus 4 minus 2 squared. Now just work order of operations like we did before. Subtract inside the parentheses. So that would give us 0 minus 5 is negative 5 squared. 4 minus 2 is 2 squared. Next step, square both of those numbers. Remember, when you square a negative, you always get a positive value in return. Take the square root. Negative 5 squared would be 25. 2 squared is 4. Add those together. We've got the square root of 29, which if we put that in our calculator and round to 1 decimal place, it's about 5.4 for our final answer for that distance. Again, you can pause the video to fill in any parts you didn't get there. I will share this video with you on Google Docs and in our Google Classroom, which I'll explain more as we use it more frequently. And that way you can watch it at home and slow it down and pause it at any point that you want to help you with this concept. I look forward to seeing you guys tomorrow and hope you have a good rest of the day practicing the distance formula, and use your time to get your homework completed.